This show is supported by you. Stick around till the ad break to hear more.
This is a couple go for month September 26th, 2024. Keep up to date with the important happenings in Go community in about 15 minutes per week. I am Maxim.
And I'm Shay. Hello, Maxim. Welcome to our show.
Hey, nice to be here. Thank you for having me.
Yeah, this time it's the Orca Star Hour. Two people from Orca Security giving you Go news. And my secret plan of joining Orca a year ago and converting all of them to Go is slowly going according to plan.
It's progressing, although I'm not doing any Go at the moment, but maybe in the future. For now, I'm the layman, taking the position of a layman here.
That's totally fair. So we have a couple of proposals to discuss. One that's likely accepted, one that's declined. Then we have two pretty hardcore blog posts to dig through. So let's jump into it. What do you think about the web? Do you like installing applications or using applications from Chrome? Let's say Jira. Do you prefer to install the Jira application or use it from the web?
No, web. I'll go with web.
So everything we do is started to happen from, Chrome web applications. And there's a I don't know if it's new-ish code format called WebAssembly, usually colloquially known as WASM, which is all about compiling your Go or Rust code or C code or whatever to things that can run on the web. That's the goal. It doesn't make any web-specific assumptions, but basically the goal is to compile things so they can run on your browser, even if they're near native performance, and use like your hardware and your GPU and stuff like that.
The point is to not use JavaScript, right?
Yeah, exactly. People hate JavaScript and all the problems that come with it. And it's basically like a low-level thing, right? It's you won't write WebAssembly by hand in the same way you won't write assembler by hand today. Like unless you have a very super specific high-performance, position-independent code on, I don't know, embedded thing somewhere, You're going to write in a high-level language. It's going to get compiled to assembler. So WebAssembly is the same. It just runs in Chrome, basically. It's not super common to see people writing stuff and compiling them to WebAssembly. But as time goes on, I've seen more and more real projects and not just toy projects. Things like spreadsheet software. Google Sheets is not written in WebAssembly, but there are competitors in WebAssembly that are much faster and they can run Python in the cells because Python can compile to WebAssembly, like the interpret, etc., etc. So some pretty cool stuff. There's a proposal in the final comment period about WebAssembly. And I thought WebAssembly was pretty esoteric, but from the number of comments and details on this proposal, I guess I just don't know what's going on, basically. There's a proposal, have Go compile to WASM 32 a lot more smoothly. So Go already compiles to WASM, but WASM is not just one thing. There are like different flavors of WASM in the same way you have different architecture flavors, 32-bit, 64-bit, etc., etc. Go is working on WASM 32 compatibility. Go has been supporting WASM since 2019.
It had only like 64-bit or?
Yeah, most of the WebAssembly support was for 64-bit, and most of the hardware today is 64-bit anyway, so that makes sense. And Firefox and Chrome have support for 64-bit memory and et cetera, et cetera. On the server side, all hosts use 32-bit architecture for WASM. If you are into WebAssembly, maybe you're working on TinyGo or you just want to nerd out about byte alignment and how the structs line up and all these like annoying problems, this is a really, really interesting proposal to try to dig through.
Proposal is accepted or?
Not yet. It's in the final comment period, and it's likely accept. I think this is the sort of proposals that there's no debate whether you should do it or not do it. It's more like a code review where everybody already agreed it's going to happen. And it's just about, is the way I'm proposing to do it correct?
So help me understand, like, what do we gain from it? We will be able to convert Go to 32-bit WASM, which we weren't able before, or?
So the best explanation I can give, Go has support for WASM, but it doesn't really support 32-bit WASM.
Yeah.
And that's relevant because it uses less memory, and the structs will be smaller. And this is the architecture that's relevant for a few WASM hosts, especially on the back end. Firefox and Chrome, it's no problem. But if you're running WebAssembly on the back end, which makes sense, let's say you have a small function inside the node service that you want to write in WASM. If your host is 32-bit, then you want to use 32-bit WebAssembly to do so. And obviously you want to write it in Go because Go is awesome. The proposal will sort of match up the 32-bit types that you can pass from and to functions. So it'll work, and it also clearly lays out what won't work. So you can't do, for example, a generic channel in WASM 32, or you can't do a generic map, or you can't pass a function. Like these sort of more complicated types won't really work, which makes sense, right? You're compiling to a very specific subset, which is smaller, et cetera, et cetera. So it's pretty cool. There's a lot of future work as well. In the WebAssembly future, there's improvements to the API and the type system, and a lot of things that will improve there. So once that target is available, then Go could improve its compilation to work with that. It's sort of an evolving process because, again, it's pretty new. It was only introduced in 2019. So pretty cool. I don't know. WASM and all this technology is pretty cool, but I just had a lot of chances to play around with it, especially in Go. I never done Go. So this is a likely accept. If it's relevant for you, Go comment. How about you bring the energy down with a declined proposal? Tell us what's not going to go into Go, Maxim.
Yes. Not all of them go in. Some of them get declined, like this one, the file descriptors proposal. Basically, the proposal was to introduce a new API to understand if file descriptor, an internal file descriptor, is used or not by Go. So the issue was that there is a CVE that was found, and someone wanted to patch that issue on their system. So the way they have to patch it is they go through all of the file descriptors they have in their container, and they just close all the file descriptors. The issue is that there is a file descriptor, and it's called equal file descriptor. When you try to close it, Go runtime just panics because for some reason it's really important. I'm not sure why. Dig into it. Dig a bit more into it, but the important thing is that it just panics. So they wanted to have like a new API that will allow us to understand if we can close the descriptor or not. They commented some more about it, and then someone just said, why don't you check if it's an equal descriptor or not? And if it's not, then just don't try to close it.
Wait, so what is an EPAL descriptor? Is a specific type of file descriptor?
From what I understood, it allows you to check, like it provides a way to monitor multiple file descriptors to see if they are ready for some I/O operations, like reading or writing.
Oh, so if you skip the EPAL descriptors, if you close all the file descriptors but not the EPAL descriptors for the Go runtime, then it won't panic.
Then it won't panic. Yeah, you can close like the regular descriptors, but once you touch an EPAL, then your program is doomed.
That feels like a bit of a workaround, though. Like, what will happen if there are future versions of Go where they introduce other types of file descriptors that again will panic? What's the sort of a trade-off here? Why was it declined?
One of the things, like, your question is good, and they addressed it like some in a way. They said that they wanted to they want to have this interface because they wanted to like protect themselves in the future from new types of descriptors. But it looks like I don't know who checks those like proposals. Who decides if it's declined or not?
So there's a Go team on Google has a proposal weekly where they review the proposals and just decide basically.
Yeah. Okay. Sorry. So good to know. So their team decided that it's not worth it to just add a new interface for this specific thing because they think it's too niche. So they prefer to have this workaround in some areas of different projects and not quotes pollute the interface. And it's reasonable. I think it shows how much they care for their interface in Golang, which is pretty sweet. Like to not have too much garbage in it. So yeah, that's it.
The vulnerability itself, like the CVE, is super cool. It's not really about Go, so we won't go into it. It's in the Docker engine, run C, which is by the way in Go. So maybe it is worth diving into it. But it's more like a Linux thing, file descriptors, sleeps, NXX. I don't know. It's very cool. I'll just say that.
Yeah, something that if you don't close the descriptor and you somehow, exit the pod or was it if you exit or not? I'm not sure, but how somehow they're able to use that descriptor in the like aftermath of the container.
Yeah, it's kind of weird, but you run your Docker and you set your working directory to /proc/self/file descriptor, and then Docker engine calls containered, which calls Dockerd, which calls containered, which calls run C. It's like a list of forks, and then it sort of injects in the middle. I don't know, something very, very cool. When I say cool, I think clearly very well written. There are like charts, there are like ASCII animations. And it's, I can just imagine, the vulnerability researcher, like, sitting down and connecting red wire on their like, on their like board, like some, like trying to figure out what's going on. How does this connect to this? There are like 15 references to the kernel and the GitHub runtime and open containers.
Sounds wild.
Yeah, it's pretty cool. So we're putting the link to the CV as well. It's a 2024 21626, which is pretty cool. If you're into security stuff, maybe you should read it. So proposals, one that's likely accept, one that's declined. You asked, by the way, how do I know, like, how do we know this is your first time on the show? How do we know like what to talk about this week?
Yeah.
So their Go team is pretty good about it, actually. They have a board of proposals and they just list the items there in, likely accept and active and then incoming. And it's very daunting. Likely accept, you have 1. Active, you have 23, which is a lot of proposals just to discuss and think and talk about. And then incoming, you have like 700. So,
damn.
Yeah, a pretty interesting backlog to chew through. But some of these are, I guess, less important than others. As you go down the list, maybe there are some things that aren't super important.
Yeah. I might be wrong here, but it looks like there is like strong gatekeeping, which features are going into the language, which is really good because it's not always the case. At least not with Python, for example, where you have like 1,000 ways to do the same thing. Although I'm not super familiar with Go, like I don't code in it on my daily job, but it does, at least in my opinion, has like a simplicity to it, to the things that are like how you do the things.
I think there's a lot of effort has gone into let's keep Go, do one thing. Actually, recently there's been a small departure with, for example, generics. So now Go lived without generics for a really long time, and then they added it. And also iterators. Go didn't have iterators for like 14 years or whatever, and now just recently they added it. But overall, it's a very, very simple language. I saw a comparison once, I don't remember where, of languages by number of keywords, like how complicated the language is just by how many keywords and like syntax structures it has. Not even talking about like libraries and things like that. And Go is just pretty low on that list. It doesn't have a lot of keywords, doesn't have a lot of stuff. I think this gatekeeping process is a big reason why. I proposed adding a YAML to the standard library once. I opened the proposal.
Yeah, I remember.
And they rejected it.
Yeah, I remember you sent it in Slack.
That was very sad. Cool. So these are proposals, and this is how we find them. There's just a board. They're really good about documentation over there at the Go team. I don't know if I should have told that, because now, like, why would you listen to the show? You can just open the board.
I think your summaries are still pretty good.
Well, we'll see about that, because I'm going to talk about a blog post that was sent in the Go performance group over on Telegram, which I don't know what I'll do now that they arrested the CEO of Telegram and they're starting to collect user data. I don't know, maybe I'll just stay in the groups. Anyways, there's a really good blog post on Red Hat about the Go compiler register allocation, which I didn't understand. It's by Vladimir Makarov, just published 2 days ago. So it's a very, very technical blog post. It's not about anything new that's released. It's just Vlad going through Go compiler about a specific section of it and explaining like how it works. Why should we listen to Vlad? He's the maintainer of the GCC register allocator, which is enough clout for me to be scared. Like if someone is, I maintain the code of compilers. It's like, yeah, I determine the laws of physics. It's like very far away from my like applicative work. And I don't know why, but it feels like very hard and intimidating. Maybe it is, but it just feels very like, you write compilers? What the fuck? You know what I mean?
Yeah, it sounds like the zone that you're not coming close to ever.
Yeah, exactly. It's sort of magic spells that are not allowed. But this blog post actually helped me a lot with, not worrying so much about this, let's say, imposter syndrome kind of thing. Vlad just goes through how the Go register allocator works. And to be honest, I had to remember what a register allocator is. Even if you're not a compiler guru, like you can figure this out. Basically, you have a different, if you remember from like university, or maybe you learned about somewhere, you have memory hierarchy, right? You have registers, AX, BX, blah, 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 which are very, very, very fast, but very expensive. So you don't have a lot of them. And then you have like caches, L1 cache, L2 cache. Then you have your memory, like your RAM of your computer. And then you have a hard disk or like an SSD. And then you can store stuff on the network. Like the farther down you go in the memory hierarchy, the more space you have and the cheaper it is. But the larger the delay is, right? Like getting something from a network drive somewhere off of, I don't know, S3 bucket takes a lot longer to get that data than asking the registers inside the CPU. Just because of physical limitations and how it's built.
Yep.
So there's a challenge here. The variables live in memory, but you need to decide which memory. You need to decide if you're using when you compile Go code to assembler code, you need to decide if you're using registers or the caches or the main memory. Usually the program doesn't decide on the cache. That's the OS's job, but it definitely does decide about register versus RAM. And if you don't do any sort of optimization, then when you do register allocation, then what's going to happen? If you just do something super naive, like if I need a variable, I'll put it on the register now. And if I am out of registers, I'll put something in memory. You're going to have a bad time because all your CPU is going to do is switch data from the registers to the RAM and back, which is not very optimized. And I learned way back in university that there's a magnitude of difference in the performance. Like your code can be 10 times slower if the compiler is bad with register allocation. Apparently, it's the most important part of compiling. And specifically in Go, it's the part that takes the most time as well when you compile.
So specifically, the mechanism of choosing when to put something in a register and when not to, right?
Yeah, this specific part of because there's an algorithm there to see what's the most efficient way to do it. You also don't want to spill like data over a long time. It's very, there are a lot of details in the blog post, but it's very interesting because you read it from the point of view of someone who does it already in a different language, like in a different compiler. In the other compilers, the register allocator is documented well enough so you can read and understand how it works without going into source code. Go compiler's register allocator doesn't have any documentation, basically. So Vlad goes to the code and basically writes the documentation for it. And it's very cool. There's a very specific algorithm, and it's like, for every pre-order, blah, 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 calculate the next use distance. And if it's likely to be used very soon, put it in a registry. And if it's not likely, put it slightly, and then shuffle, rematerialize the input values, blah, 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 blah. Like very, very cool algorithm.
Statistical calculation of when something should be used.
So I'm not sure if it's statistic, because I think it has to be deterministic. I don't think there's any random stuff here, but I'm not 100% sure. So I'm going to be like, maybe just read it. But there is there's a lot of detail here that's very, very interesting. And once I read through it once, like slowly, I was at least, I had a lot of insight into how this stuff works under the hood. Now, I don't know if it's super relevant for my day-to-day work, but it's definitely nice to know that there were recent improvements for more sophisticated algorithms, and some things that jump back from university, graph coloring and things like that, which are pretty cool. Basically, you can try to jump directly into the algorithm, but the summary of it is, from what I understand from the blog post, is that you have a graph of where every node is a variable. Edges are variables that live closely in the same time. And
so if you have a loop, like a for loop, then all of the variables inside that for loop are probably close.
Yeah, and the problem is that if they're close, you don't want to put them on the same register.
Yeah, because then you'll have to switch them.
Yeah, you'll do a lot of shuffling. So what do you do? You do the thing, you color them. So you can't put red next to blue, and you can't put blue next to yellow, and you need to color the graph. And then your number of colors is the number of registers you have. And then that's why it's important to know to which architecture you're compiling and which hardware you're going to run on, right? Because in different hardwares, you have different amounts of registers. Pretty cool.
Yeah, so I think this is why we're saying that this is like the hardcore software engineering, because I really have flashbacks from computer science courses, and yeah, sounds terrifying.
A bit intimidating. But one thing you can take away from this, I think, is knowing that this is very important. It can inform you how to write your code. For example, you might structure your functions to be smaller, or so you reduce the number of live variables at any given time. Now, I don't think you would specifically do it for performance, but I just think if you read about it and you know about it, and then in the back of your mind while you're programming, you suddenly remember, look at a function, it has a ton of variables. You suddenly remember, oh, the compiler is going to have a hard time optimizing this. It might drive you towards writing better code. Again, not specifically about performance, because if you're worried about performance, you should profile. You shouldn't pre-optimize the compiler optimizations. You're not smart enough to do that, and I know I am not.
Yeah, but it's another plus for not writing huge functions.
Yeah. Just write less shitty code, which is good, I think. It's important, especially now that AI is writing all our code. Another reason to go through what the AI is spitting out and not taking it at face value is very important.
Yep.
So a cool blog post. Thanks, Vlad, for posting it. I was enamored by it, but I don't know how useful it is. But very, very, very cool.
Yeah, that was interesting. So the next one, this new feature under the blog post is called What's in an Alias Name. It's basically talking about how do you manage refactoring your code base with types. So if you want to refactor a large code base, you want to, for example, move some definitions like functions, variables, types from one package to another, then you have the option to reference, for example, for functions, you can just write a wrapper function from, for example, package 2 that will reference package 1. And then each time someone wants to access that function, it can access the function from both package 2 and package 1 because they both point to the same function. But with types, it wasn't so easy because if you have like package 1 and package 2, and you want to and you have a type called T, if you want to define the same type in package 2, then Go will treat it like a different type. Even though it's defined in exactly the same way, there is like no way to point from type to another type. But now there will be, because they're introducing something that is called a type alias. So the way you define it is like type A equals some other type, and the equals indicates like it's an alias. And why is it useful? Because now you won't have to like do some tricks and change your functions to receive either package 1T or package 2T. You'll just be able to reference whatever package you want. And because it's an alias, you'll be good to go with both. So it's it's a pretty nice little addition to help, I guess, mostly big projects to migrate from packages.
Well, what we had was, if I understand correctly, what we had was the like normal aliasing. So you could alias a thing, and then Go. When was generics? 1.18 introduces generics, where you have the type and you're in a square brackets. You have like constraints, but you couldn't alias a generic thing. So I think it makes sense.
Yeah, but I think it's not only generics. It was in general, like you couldn't alias a type, and now you can alias a type, and you can alias a type generic, which is, I missed it. It's also like pretty sweet because you can alias a generic, but only like a subset of this generic, I think, if I'm not mistaken. I might be, but you can like pass exactly the list of types from this generic that you want to alias. So it's like a combination, I think.
Yeah, you can alias the generic type with specific type constraints. You don't have to conform to what the original type was.
Exactly.
So this is not released yet, right?
Nope, it's going to be released in the next
Go version.
Like what it's going to be, Go 1.24 is going to be.
Looks like if you want to turn on the experiment, you can turn on the environment variable alias type params, which is pretty cool.
So when I read about it, I didn't think about this issue at all. Like it's a surprise to me that there is a need for this, because we just talked about how they are wary of adding new features, and they don't want the code to be too messy. But apparently this is an issue for big projects, so good to know.
Yeah, I think it's important to remember, usually my Go projects, they tend to be pretty small, just because even if they evolve really well and they become like huge backends, microservices, whatever, they don't feel bloated. Like they have just enough code to make everything work. And refactoring usually is pretty easy, just because the tooling is pretty good and it's a statically typed language, and it makes sense that it's pretty good, easy. But the moment you're working with like huge projects that also have some of their parts open source, maybe have thousands of consumers to your various sub libraries. I'm imagining projects like Kubernetes, right?
Yeah.
So migrating or refactoring things in such a huge project without breaking all the dependents, like all the people that import the code, is really a technical challenge.
Yeah, so I'm imagining that if someone wants to move a type from one package to another in Kubernetes, then this will make his life a lot easier. That I'm sure.
Or they could just not use Kubernetes, but that's a different. I'm wondering, I can just imagine a line on the CV, refactored a single variable type, a generic variable type in Kubernetes, and someone reading it and being like not technical enough to understand how much work is it, and being like, refactor the single type, but this guy doesn't do anything. And then someone who actually knows this proposal, know how much work went into it, work of 100 people for like many years. It's like, oh, that's amazing. Pretty cool. The blog post is by Robert Griesmer. Thanks, Robert. Very cool. I think that's the blog posts for today. We wanted to talk about some more, but looks like we're gonna need to do it pretty fast. So time to go to the lightning round. Lightning round. First up on the lightning round, Victoria Metrics released a series of blog posts about Go concurrency and parallelism things in the sync package. Very reminiscent of a talk I recently heard from Yarden Leifenfeld in the Go for Con Israel. The latest one, Go single flight, melts in your code, not in your DB. Explains the Go single flight sync primitive, which is really, really cool. If you don't know what single flight is, you should. And it introduced a new thing. New thing for me, a cache stampede. Do you know what a cache stampede is?
No idea.
So it's apparently when a lot of different threads talk to the cache and the cache has a lot of misses. So it asks the DB a few times for the same thing, which is exactly what the cache is supposed to prevent. Single flight, which means just a single thread is going to go through this piece of code. The rest are going to wait for the result and get the same result, can prevent a cache stampede. Very nice wording for that one. What's next?
Okay, so next, should Go test run fail if it doesn't find any tests? So let's say we're trying to run a test and we mistype, put a typo in the name of the test. Right now, if I remember correctly, because you told me, the Go run test just outputs a warning and it passes, right?
Exactly.
So do we want it to fail or not? If you ask me, then I would just go to how Python works, because that's mostly what I do today. In Python, it fails, which is pretty... it makes sense to me, because it's probably a typo or something, because I wouldn't just run those tests, like those commands for tests, if I know there is no such test. So
and you can worry about it from the other side as well. Imagine you're running in CI and you're like, run all the tests that starts with Maxim, and then slowly you change your name and the CI test doesn't do anything anymore. It's not failing.
You just have like empty passes.
So there's a live discussion on it. I'll just say the other side just so this show feels controversial. It passes today, and you can use it to just run benchmark tests. So you can say like -run empty string, no test fits this regis pattern, and then -bench everything. So it doesn't run any unit tests, but it runs all the benchmark tests. So this behavior will start failing. So it's not very easy to decide, like, do you want to break this behavior for other people? What happens if you do -run foo, a test that does exist, but also pass -skip? Should it fail? Like you wanted it explicitly to not find anything. Kind of weird. Not obvious. Not obvious.
Yeah, because it breaks. Maybe maybe there's like a point to stay the way it is, but I don't know.
They're looking for a solution. The thread is open. The link is in the show notes. If you have any clever solution to help save the people, go post it now. And finally, on the lightning round, it's just a cool link to a cool Twitter thread by Felix. I'm not going to pronounce this correctly. I'm sorry. Felix Geisendorfer, who's a senior staff at Datadog, working on Go profiling. And they found a bug in the flame graph Go runtime, Go exit in the visualization. It's just a super technical Twitter thread, which is the reason I like this sort of tech Twitter thing, because people have to write a very technical blog post, but they have to do it in very short paragraphs, which fit with my attention span. The TLDR is 0 values messed up with the visualization. And Felix goes through the fix and then the improved screenshot. And he says, "Thank you, Datadog, for allowing me to improve the Go ecosystem as part of my job." And I fully agree. Thank you, Datadog, for letting Felix write these cool Twitter threads and enriching my life a little bit as well. Very cool stuff.
Go Datadog.
Yeah. If only your service wasn't as expensive as like gold and oil, and maybe I could say I'm a happy user, but not right now. That's a show, Maxim.
Yeah. It was really quick. Like we went over a bunch of stuff. I didn't understand half of it, but it was nice.
The show's going to come out soon and you could listen to it.
Yeah. Till then, I'll go over the stuff and I've learned a bunch. Nice. Thank you.
Thanks for coming on. Let's move to a quick ad break. Welcome to our ad break. This week, we're going to do something a little different because Maxim is here and Maxim is from Orca. We're going to talk a little bit about Orca because we have open roles for Go developers. Maxim, how's Orca?
Orca's great. Like I've learned like a ton since I came, which is almost 2 years already. And now we're recruiting Go developers to the sensor team, basically the team that will work on the sensor that Orca will deploy to their customers, which is really exciting. We didn't have one till now.
Yeah, we had like partnerships and things like that with other companies, and now we're doing our own. Very, very cool. The role is in Warsaw in Poland. So all our European listeners, perk up your ears. It's Go, Python, Docker, Kubernetes, Serverless, Django, Postgres, Elasticsearch, Kibana, Spark, Airflow, Iceberg, NoSQL, Kafka, SQS, Redis, Linux, AWS, Azure, GCP, Oracle Cloud, and Ali Cloud. That's like the tech stack. And it's just we have 4 different roles where Go is very much a benefit. There's backend developer, runtime security researcher, agent developer, and the DevOps engineer. And for one of these roles, like 4 years in Go is a specific requirement even. And if you have knowledge with eBPF technology, security stuff, programming skills in Rust or C++ or C, vulnerability research or reverse engineering, good knowledge of Docker and Kubernetes internals, all these sort of things, deployment tools, monitoring tools, Prometheus, Terraform, Helm, blah, blah, blah. These are all benefits. We're going to post the links in the show notes to all these 4 roles. And even if these job opportunities are the great fit for you, if you know someone who could be a good fit, let us know. We both work at Orca. I'm working a lot with this new team. It's very exciting, and they're doing stuff pretty right. I think it's a great time to join this
yeah, they have like strong start.
And it started like sort of near my team, like the CTO office and things like that. It was pretty cool seeing things like form up. And now that the team is finally forming up into an official thing and we have so many open roles, it's just a really great opportunity to join Orca, where we work. And you get the chance to work with Maxim and I. I don't know if that's a benefit or not. So the team is very recently formed. I asked Anton, the team lead, if he wanted people from the podcast to hear about these roles. And he was like, "What? For sure. Like, people in Go communities are exactly the people we want to find." So I think hand in your CV, join the team. You need Polish citizenship or a work visa for Poland. But if that's relevant for you.
Yeah, so it has to be like on site. Yeah.
Yeah. The job is hybrid. They're not in the office every day, just like you and I. But you have to be a Polish citizen or have a visa or something like that. Not super strong in Polish law. Prefer to learn about the Go compiler other than other countries' work permits. But just an FYI, this is not like a fully remote position. So let's do the normal ad break now that you heard about Orca hiring and you might be furiously handing your CV in now. This show is supported not by Orca. They didn't sponsor us to talk about this, by the way. This show is supported by Patreons who pay for the show every week. We really, well, Maxim doesn't because he doesn't get any money out of it. But I appreciate all your support. And I know John does as well. We don't actually make money out of it. It's mostly us paying our editor and hosting fees and just trying to maintain this very expensive hobby of doing a professional podcast. If you want to reach us, you can find us at cupago.dev, where you can find links to our Slack channel, find our store where you can buy some cool swag, or email us at news@cupago.dev. That is news@cupago.dev. Another way to help the show, if you like it, is to leave a review on Spotify or Apple Podcasts or wherever you listen to your podcasts. This, I think 2 weeks ago, or maybe even last week, there was a new technical podcast on doing the rotations. It's the Pragmatic Engineer, the Gurgly Orcas. So he has a new podcast. He just shared a post about, oh my God, getting up the rankings meant so much for exposure for the podcast. So if you didn't rate it yet, that could be cool. We're not expecting to be like the number one podcast ever. It's obviously a very niche subject, but getting into more Go developers' ears could be very cool. That's pretty much it. Thanks, Maxim, for joining. I hope you had a good time.
Thank you for joining.
And if you want to find Maxim, join Orca. He's not big into follow me on Twitter or anything like that. So I guess your best case is to hand in your CV.
Go do it.
All right. Thanks a lot for listening, everyone. Program exited.
Program exited. Goodbye.